Hello and welcome back to another episode of Math with Sohn. Today we are going to be taking and graphing parabolas that are in different forms. So let's say we had a parabola in vertex form and let's say we had a parabola in factored form. Both of which can be graphed with a graphing calculator, of course, but what if you wanted to graph them by hand and you didn't want to FOIL it out? It's important to recognize the three forms. These are the two that are not standard. The middle one that I'm writing up here, this would be the standard form of a parabola, where you would have to use negative b over 2a. If you're interested in that, there's another video. This is for the unique forms, the vertex form and factored form, both of which can be FOILed and distributed and multiplied out to become this, but it'd be a lot more work, and they can be actually graphed as they're sitting. So standard form, you got your own video, goodbye. Vertex and factored form. Vertex form is what I call change the sign, keep the sign, and it is the function transformation format, which makes the vertex change, keep 3, 4 in this case, right by 3, up by 4, dot. And for me and my students, I really only care about making sure the parabola faces the right direction and you have the right vertex with vertex form, but you could plug in a point or even think of the two, quote unquote, it's similar to the slope, but only for the very next point, to register that this is going to definitely go down because it's negative, and it is going to be going down by approximately 2 and over 1 only for that next point. And it's not even an approximation. That very next point will go down by 2 and right by 1. So that point right there would be at 2, 2, and it be symmetrical. So over here at 4, I would also need to be up at 2. But for me and my students, I don't really ask that. I just ask, hey, here's your vertex, graph it, let's look at it, let's do the domain and range, that sort of thing. Speaking of domain and range, domain is all real numbers, but the range is y is less than or equal to 4, which could be also interpreted as from negative infinity to 4, including the 4, so it should have had a bracket there. Okay? So vertex form, by far the easiest and quickest, especially if you've already done function transformations, whereas factored form, that one will require a little bit more skill and will incorporate something we have never done before, which is plotting the x-intercepts. And the x-intercepts are the solutions to these two factors, and the solutions to the factors are going to be the opposites most of the time. But really what you should be doing is setting them equal to 0 individually. X minus 4 is equal to 0 and x plus 2 is equal to 0. To find out the x-intercepts are in fact the opposites, 4 and negative 2, when you solve those little individual cute equations. So we got 4 and we got negative 2. And these are our x-intercepts. And the parabola, just like this one over here, has to be symmetrical. So if it has to be symmetrical, that means that somewhere kind of over here, I am going to end up having like the parabola, and it is either going to face up or down according to the number in front, and the number in front is a positive 1. Therefore, it will be facing up. And if I need to figure out where is this symmetrical value, I need to find the middle between negative 2 and 4. And some of you are going to be like, it's 1, and you're going to get it right away. But other problems you might not know, and if you don't know what the middle between two things is, you can always use the midpoint formula, which is just the average, add them up and divide by 2. If we add these two numbers and divide by 2, you do end up with not 1. Oh, you do. You end up with 1. 2 over 2 is 1, which makes sense because this looks like it's at 1 in the middle. And that's very helpful because that is an important value of our vertex, is the x value. And if you have any x value and you want to find the y value, you can plug it in. If we plug in this x value of our vertex of 1, we can find the y value. If we plug in 1 minus 4, and then 1 plus 2, we end up with something unique here because this is always going to happen. You're going to end up with these being pretty much the same number but opposite signs. This is negative 3 and this is positive 3. And if you multiply negative 3 and positive 3 together, you get negative 9. So apparently our vertex is way down here at 1 comma negative 9. I almost didn't even need to rewrite it. It's right there. And it's going to have to go up, which we already knew. And we have a nice pretty parabola. I tried taking my time to make it look a little nicer. It could have been rounded at the bottom. And the only other thing that you may be concerned about is the y-intercept. The y-intercept of this graph is really easy to figure out. It's just 4, negative 4, times 2, which is negative 8. That's a little trick. You can do a little partial thing. The 4 and the 2 can multiply and be giving you that y-intercept. But you can also always find your y-intercept by plugging in 0 for x, which would give you the same thing. 0 minus 4 times 0 plus 2 ends up being 4 times 2 and giving you the same 8. Okay? Domain is all real numbers, negative infinity to positive infinity. The range is y is less than or equal to negative 9, or you could write from, oh no, it is not less than. It's going up from the 9. It's greater than or equal to negative 9. So you could say from negative 9 to positive infinity because it's going up from the negative 9. Arrow. All right. So that's going to do it for this episode. Until next time, stay positive, and I will see everybody later. Bye.